Welcome to Train Signal. You're watching a video on DHCP. In this video, I'm going to introduce you to what DHCP is and the role it plays in a network. We're going to take a look at how to configure DHCP, including installation, authorization, setting up scopes, configuring scope options. Then I'm going to talk about the challenges we face when using DHCP in a routed network and how we overcome those challenges. First of all, what is DHCP? Well, DHCP stands for the Dynamic Host Configuration Protocol. This means exactly what it sounds like. With DHCP, hosts can dynamically receive their TCP/IP protocol configuration. See, now before DHCP, network administrators had to go out to every single client. So every one of these clients you see here, one by one, they would have to go in and configure their TCP/IP configuration. Now, we could simply configure a DHCP server with a database of information, and then that information can dynamically be sent out to all of the clients. This can not only save us a lot of time, but also helps prevent a lot of the mistakes that were made when configuring clients manually. Alright, so basically, how does DHCP work? Well, as I stated a moment ago, we have a DHCP server which holds a database of IP addresses. When a client has been configured to automatically obtain an IP address, it attempts to get one of those IP addresses from the DHCP server. Now there's a four-step process known as DORA, D-O-R-A, which is really nothing more than an acronym that we use to help remember the four steps, or the names of the four steps, which is discover, offer, request, and act. Now let me lay this process out for you in a little more detail. Here I have a server and a client, and the client has just come on the network, it's just been turned on, and it's been configured to receive its IP address automatically. So the first step would be D, or discover. In this first step, the client will send out a broadcast looking to find or discover the presence of a DHCP server. It's basically like a client yelling out, "Hey, I'm looking for an IP address. Is there anyone out there who can help me?" This broadcast is then sent out to the entire network so that any and all DHCP servers that might be out there will hear it. Now the second step is O, or offer. In this step, all DHCP servers who heard the Discover broadcast will send out an offer. And it's basically like the DHCP servers responding back with, "Hi, I'm a DHCP server, and here's an IP address if you want it." Now the third step is R, or request. In this step, the client will then send a request to the first DHCP server in which it received an offer from, asking to have a lease for that IP address. Now, all IP addresses that are given out by a DHCP server are done so in the form of a lease. This means that the client can only keep the IP address for a specified amount of time. So the request step is basically like the client saying back to one of the DHCP servers, "Yes, thank you. I would like that IP address." Finally, the last step in the DORA process is A, for ACK, which is the official name of the packet which is sent out on the network, but it's more commonly known as an acknowledgement. Now in this step, the DHCP server acknowledges the request, issues the lease to the client, and makes note of that lease in its database so it doesn't give that IP address out to anyone else during the lease. It's basically like the DHCP server saying back to the client, "Okay, that IP address is yours and you can have it for X amount of time." Any of the other DHCP servers which had sent out an offer but did not receive a request simply put the IP address which was offered back into their database. So let's review these four steps together one more time. The first step is the client yelling out, "Hey, I'm looking for an IP address. Is there anyone out there who can help me?" Then the DHCP server responds back with, "Hi, I'm a DHCP server, and here's an IP address if you want it." Then the client says, "Yes, thank you. I would like that IP address." And finally, the server responds with, "Okay, that IP address is yours, and you can have it for X amount of time." Now, this is how the process works when a client is attempting to obtain an IP lease for the first time. When a client needs to renew their lease, the process is a little bit easier. The DHCP renewal process is only two steps. Since the client already knows about the DHCP server that gave it its IP address in the first place, it doesn't have to discover it. So the client can go straight to the request step and make that request to the DHCP server to have its lease renewed. And it's basically like the client saying, "Hi DHCP server, it's me, client again. Can I renew my lease and keep my IP address a little longer?" Then the DHCP server responds back with an ACK or acknowledgement. "Sure, you can keep this IP address for X amount of time." This usually tends to be a fairly quick and painless transaction. Now, one thing you should know is that the client does not wait until the lease is completely used up to attempt to renew. It will attempt this process when half of the lease duration has passed. So for example, if the lease was for 8 days, which happens to be the default duration, we'll see that when we look at the server, the client would attempt to renew after 4 days, which is half of that lease. If the DHCP server is there to respond, then the client would have a fresh 8-day lease and would try to renew again in 4 days. If the DHCP server was not available, then the client would keep its lease, since there's still 4 days left, and would try again in half of the remaining time on that lease. So for example, in this case, it would try again in another 2 days. And the client will continue this process. It will continue to try every time half of the remaining lease duration has passed until 87.5% of the lease duration has expired. At this point, it will attempt to renew with any DHCP server, and if it still can't renew, well, when the lease is completely up, it starts the DORA process all over again. So just to kind of review here, why do we use DHCP? Well, we use it because having to go out to hundreds of thousands of computers and give them a static IP address not only can be quite time consuming, but also opens the door for an awful lot of mistakes to be made. So now that we know what DHCP is, how it works, and why we want to use it, let's get right into it. Let's go over to one of our Windows Server 2008 computers and set it up as a DHCP server. For this demonstration, I'm going to go ahead and connect with a Server 2008 computer called New York Member 1. So let's go ahead and connect to that now. Okay, the first thing we need to do, if we're going to install pretty much any significant network service, it doesn't have to be just DHCP. Any network service on a server requires that that server have a static IP address and not be dynamically getting its IP address from another DHCP server. So what I'm going to do is I'm going to click on Start and open up a command prompt window. In the command prompt window, I'm going to type ipconfig/all. And you will see here that says DHCP enabled, and the answer is no, which means my IP configuration is static on this machine. So let's go ahead and close that window. The next thing we need to do is add the DHCP server role to this computer. We do this through the Server Manager. So I'm going to click on Start and select Server Manager. In the Server Manager window, we click on Roles and then click over here where it says Add Roles. Here you see a list of roles that are available on this server, and in this case we're going to check the box where it says DHCP server. Now you'll notice it was kind of a very quick flash, but there was a quick check that took place to make sure that this machine was ready to be a DHCP server. As of, for instance, it checked to see that we had a static IP address. So if you forgot that step on your own, Server 2008 is smart enough to check that for you. So let's go ahead and click on Next. And here we get an introduction to what DHCP is. I'll click Next again. Now on this screen, we have to select a network connection to bind the DHCP service to. Now, you'll notice I only have one connection to choose from, so there's not a whole lot for me to do. But if I had more than one network connection on this computer, I would have to select which one or multiples that I would want to bind to. What this means is I might be a computer that has 2 network cards, but I might only want to provide DHCP services to one of the networks that I'm connected to. That way you don't interfere with clients on the other network. So I'm going to go ahead and click Next. Now this screen is taking care of something that we're going to look at in just a few minutes, which is some of our DHCP options. You'll see later on there is the ability to configure DHCP options, which is additional IP configuration information for our clients to use beyond just their IP address. But because DNS is so significant to a Server 2008 network, it assumes that you're going to want to go ahead and give out a DNS suffix, which we have here in our parent domain, globalmantix.com. and then also at least a preferred DNS server address, if not a preferred and an alternate. So I'm going to go ahead and type in an IP address of our preferred DNS server. And then I'm going to click on this button that says validate. Now what this does is it sends a quick little query out to see if that is the IP address of a DNS server which is responding to requests. In this case, you'll notice it came up valid, so we're ready to go. So I'm going to go ahead and click on next. Here it'll ask me if we're going to be using WINS. Now WINS is something that is used to resolve something called NetBIOS names. This is something that is really in place for the purposes of backward compatibility. If we have some older, we'll say Windows 95 or 98 clients on our network, they still use the older NetBIOS names, and we may need WINS to resolve those names for them. This is something that was real prominent back in the days of Windows NT4, and we really haven't seen a whole lot ever since. So I'm going to go ahead and leave WINS disabled on this network and click next. Okay, the next option we have here is to add or edit a DHCP scope. We have no scopes yet, so there's none to edit, but we could add one. I'm going to not add one at this point because I want to show you how to add a scope after we install DHCP. So let's go ahead and click on next. And here we have the configuring of DHCP v6 stateless mode. Now this is something that we aren't going to worry about in this demonstration because IP version 6 is not enabled on this network, and if it's not enabled on your network, then you just want to go ahead and leave it alone. But if you were using IP version 6, we could choose to either enable stateless mode, which you'll notice here means that the clients will automatically configure themselves without using the DHCP server, so that's kind of like disabling DHCP version 6, or even though it says enabled. Or you can click disable DHCP version 6 stateless mode, which in actuality is kind of like enabling DHCP version 6, which means that you will configure DHCP v6 on this console. So I'm going to click enable stateless mode, which means it's like we're disabling it on this machine. Click next. Now here again we have our IPv6 DNS settings. We don't really care about these settings because IPv6 is not enabled. You'll notice the parent domain is already populated, and right down here the next button is gray, and I can't click on it because it wants me to enter an IP address. So I'm just going to go ahead and type in localhost. That ::1 is localhost for IPv6, just to satisfy it so I can go ahead and click the next button. Now we have the opportunity to authorize the DHCP server. All DHCP servers since Windows 2000 have been required to be authorized with the Active Directory domain services. The reason for this is before we had authorization, we ran into a problem where localized administrators would make the decision to implement DHCP without realizing that another administrator had also implemented DHCP. The two or more DHCP servers would very often have overlapping IP ranges, which meant that they would each independently hand the same IP address out to different clients. Now obviously this would be a problem because every machine must have its own unique IP address. With authorization, this is something that is required to be done by somebody of an enterprise administrator level. This way, somebody who is responsible for the design of the entire network or who oversees the entire network can have a handle on things and can prevent this type of conflict. So as we can see on this screen, we can either use our current credentials if we are currently logged in as an enterprise administrator, or we could use alternate credentials if we are not the enterprise administrator. This is where you would call an enterprise administrator in to enter their credentials. Or you could choose to skip authorization at this point and come back to it later. Now, for the sake of this demonstration, I'm going to go ahead and skip the authorization because I would like for you to see how to authorize after DHCP has been installed. So I'm going to go ahead and skip the authorization and click Next. At this point, we get a confirmation screen, which pretty much just reviews everything that we've just done. You'll notice the warning, this DHCP server must be authorized before it can service clients. We're not going to worry about that because we know that that's what we've done. And I'm going to go ahead and click Install. Now, this installation is probably going to take, usually takes about 30 to 60 seconds. So rather than stare at this bar go across the screen, I'm going to go ahead and pause the video and I'll be right back with you. Okay, as you can see, the DHCP server installation has succeeded. So I'm going to go ahead and close this wizard. And you will notice here that under roles, 1 of 16 is installed. It shows DHCP server. Matter of fact, if I expand roles over here, you'll see DHCP server. So I'm going to go ahead and close the server manager. And what I'm going to do is go back to Start, Administrative Tools, and you will notice that we now have DHCP as a choice on our menu. This will open up the DHCP console. This is where we can manage our DHCP servers. So let me go ahead and expand this, and you'll notice over here we have New York member 1. I'm going to go ahead and expand that, and you'll see there's an entry for IPv4 and IPv6. Again, we're going to not worry about IPv6 for right now, but I do want you to notice the little red down arrow here next to each one of them. That red down arrow is what lets us know that this server is not yet authorized. You may recall during installation, we chose to skip authorization so that I could show you how to do it from this console. What you do to authorize is you want to click on your server and then go ahead and click the right mouse button, which pulls up a menu, and on that menu we see the selection for authorize. So I'm going to go ahead and select authorize, and boom, look at that, nothing changes, just as you would expect, right? Now what I need to do here is right click and select refresh, and you notice the cute little red down arrows go away. Now one other thing I want you to notice if I right click one more time is that the location on the menu where it previously said authorize, it now says unauthorized. So if you need to go in and take that authorization away from a server, you can do so by selecting unauthorized. This pretty much just toggles back and forth. Alright, so now that we've authorized our DHCP server, let's go ahead and expand IPv4, and you'll notice there's just not a whole lot there. All we have is one simple little folder here that says server options. We're going to come back to these server options in just a few minutes, but first I want to talk to you about scopes. If I click on IPv4, you'll see over here that it's telling me that what I need to do is add a scope. Now, what is a scope? It says right here, a scope is a range of IP addresses assigned to computers requesting dynamic IP addresses. So, quite simply, it's a range of IP addresses that are going to be handed out to the clients. So I'm going to come over here, and I'm going to right click on IPv4 and select New Scope. This opens up the New Scope wizard. In the welcome screen, I'm going to click Next. I have to give our scope a name. And then I will go ahead and click on Next. Now I have to give a range of IP addresses that I'm going to hand out. Now the network here in New York uses the 192.168.10 range of IP addresses. So I'm going to put in 192.168.10.1 as the beginning and 192.168.10.254 as the end IP address to give us the full range. Down here we then enter the subnet mask. You can either enter it in with the traditional 255.255.255.0, or you can even put in the number of bits that make up the network ID of your IP addresses. So I'm going to go ahead and click on Next. And now we have the opportunity to add exclusions. Now, exclusions are for IP addresses that may fall within the range that you've designated that have already been assigned, or you want to hold aside to use for the few machines on your network that might have to have a static IP address. So I happen to know that all the servers that require static IP addresses on our network have a range from 192.168.10.200 to 192.168.10.254. We chose to put everything in the 200 range for our servers. So I'm going to go ahead and add that, and that will prevent this DHCP server from handing out those IP addresses to any clients since they're already being used statically by our servers. I'm going to go ahead and click on Next. And now we get to our lease duration. You may remember that when I was going through the DORA process, I had mentioned that the default lease duration was 8 days, and you can see that here. You can choose to leave this alone. You can choose to make it a shorter lease. You can choose to make it a longer lease. Very often it's just left alone. The default 8 days is perfectly acceptable in many networks. Primarily the reason you would either increase or decrease the lease duration would have to do with how often there are changes to your network configuration. If computers stay primarily in a static location, then it's okay to have a long lease duration It's not really going to hurt anything. There's no reason to have the extra network traffic of renewal if you know that everything's going to stay in place. But if you're in an environment where the configuration is going to change frequently, then you would want to have a shorter duration, which would generate more network traffic with all the renewals, but would also accommodate for clients that are constantly changing. So I'm going to go ahead and leave the 8-day lease and click Next. Now we have the opportunity to configure DHCP options. I can choose if I want to configure these options now or do it later. I'm going to go ahead and choose to do it later because, again, I would like to show you how it would happen outside of a wizard. What these options are is this has to do with like back in the installation wizard when we assigned a DNS suffix and a DNS server. This is additional configuration information that we will give out to our clients along with their IP address. So I'm going to go ahead and click Next, and then we'll come back and visit these options in just a minute. And this completes the new scope wizard. So I'm going to click Finish, and you'll see that I now have a scope. Uh-oh, there's our little red down arrow again. When you see a little red down arrow on a scope, that represents that the scope is not active. By having the scope in place but not active, it has been configured, but it cannot yet be available to give out IP addresses to the clients. In order to activate this scope, I'm going to right-click on the scope and simply select Activate. And you'll notice once again that the little red down arrow goes away. I will also show you that if I right-click again, you'll notice that Activate became Deactivate on the menu. So if I wanted to deactivate the scope and stop handing out IP addresses, I could do so this way. Once we have a scope in place which has been activated, you will see here that we have a number of additional options available. Here we have address pool. This is what shows us what addresses are in this scope. Here we have the 192.168.10.1 to 254 range. You'll see here the exclusions of 10.200 to 10.254. Now here we have the address leases, which right now is going to be empty, and I will show you this changing in just a moment. But for right now it's empty because we haven't actually handed out any IP addresses yet. Here we have reservations. Now reservations is something that a lot of people tend to get confused with what this is versus an exclusion. Now a reservation is where you take a specific IP address from the range that you hand out and you reserve it for one specific host, one specific client. So if you have a client out there that you want to always have the same IP address, a couple of, for instances that come to mind is maybe a client that has to run certain services and you have certain firewall exceptions set up to communicate with that one machine. You would want that machine to have the same IP address all the time. Or another, for instance, is one thing that's real common would be a printer. If you had a network interface printer, a printer that has its own Ethernet card that resides on your TCP/IP network with its own IP address, you don't want that IP address to be changing. But at the same time, you don't really want to go over to the printer and configure it statically. I don't know if you've ever done that. I certainly have, and it's generally not fun. The menus on a printer are usually not very user-friendly. So this is a way to give that printer a static IP, but have the printer think it's getting it dynamically. So we'll come back to reservations as well in just a moment. And then our last selection down here is scope options. And this is where you will see that we have our DNS server and our DNS domain name already populated. And this is because these were created during the DHCP installation process. If we want to have additional options handed out to our clients by the DHCP server, we could have done so during the scope creation process, but again we skipped it so I could show you the more manual way of doing it after the fact in case you ever have to make changes. So let's go over here to our scope options and right click and select configure options. In this window you will see that there is quite a long list of various options that we could hand out. We're not going to go through this entire list right now. What I'm going to do is I'm going to select what's probably one of the most common options out there, which is the router option. Now this option is what would define the default gateway or router that a client would use to get off of its network. So I'm going to go ahead and check the box, and down here You could put in the name of the router. If you have a name, you could type it in and then resolve to the IP address. Or if you know the IP address, you could just simply type it in. So I'm going to put in the IP address of our default gateway and click Add and click OK. And you will see here now that besides the DNS server and domain name options that we had before, we also have the router option. Now, these scope options look very similar to this extra little folder we had down here that says server options. Matter of fact, if I click on server options, you will see that we have the same entry for DNS servers and domain name. But wait a minute, where did the router go? Well, the DNS server and domain name were something that we configured during the installation of DHCP altogether, and so therefore is going to apply to all scopes, all IP ranges that we will install on this server. That's why it's listed as a server option. Under scope options, we added an additional router that's going to be used by this particular range of IP addresses. So let's go ahead and let's turn on a client machine so we can give out an IP address. So let's go ahead and put our server away for just a moment, and I'm going to boot up New York Vista 1 virtual machine. This is a Vista client that has been configured to dynamically receive its IP address. Okay, the computer is booted. I'm going to go ahead and open up a command prompt, and in this command prompt window, I'm going to type ipconfig/all, and what this is going to show us, there's a little extra information here. Let me scroll back up. Is you're going to see here that we've been given the 192.168.10.1 IP address. You'll notice that we also have a default gateway of 192.168.10.200, which we had given out as part of this scope, but that we also know that the DHCP server's IP address is 192.168.10.211, which is the IP address of New York Member 1, the DHCP server. So this has worked. Let me go ahead and, I'm going to leave this window open for just a moment because we're going to come back to it to look at something. So let me just go ahead and go back to our server, because what I would like to show you on the server is if I click on the address leases entry here, you will see that we now have a lease out there. 192.168.10.1 has been given out to New York Vista 1. Great. So everything is working just the way it's supposed to. But one other thing I want to show you is this reservations. Let's say New York Vista 1 was a client that for some reason had to have the same IP address every time. So what we're going to do is let me pop back over to Vista 1. Over here, you'll see that one of the entries here was the physical address 000C2912C7EB. That physical address is the computer's MAC address. When a client does a discover, when it does its DHCP discover broadcast, you know, the one from the DORA process where it says, "Hello, is there a DHCP server out there? I need an IP address." When it does that, all it can use to identify itself is its MAC address. So we're going to use this MAC address to tell the DHCP server what machine we're making a reservation for. So let's close our Vista machine and go back to our server machine. And in reservations, I'm going to right click and select New Reservation. Now I'm going to give the reservation a name. I'm just going to call it actually New York Vista 1. Somewhat appropriate since that's the name of the computer. And this time we're going to reserve, let's say 192.168.10. We'll say 50 just to pick an IP address. And it's right here that we need to enter that MAC address. So 000C2912C7EB. And go ahead and click on Add and close. So what we've done is we've now made a reservation of the 10.50 IP address for the Vista 1 client. So let's go ahead and close our server for just a moment. And let's go ahead and go back into Vista 1. And what I'm going to do here is now I'm going to put in an ipconfig/renew. And now you will see that we've been given the IP address of 192.168.10.50, the IP address that we had reserved for this client. So let's again put the Vista machine away. Let's pop back over to our server. And when we click on address leases this time and refresh the window, you will notice that the 10.1 address has not been given out. 10.50 has been given out, and here you'll notice that it has been set up as a reservation. Now, one other thing that you should know about a reservation is not only will New York Vista 1 get this IP address every time it goes looking for one, but this IP address also will not be given to anybody else. So it's almost as though we've just created a static IP address for this machine, but without having to walk over to the machine and configure it statically. And that can come in real handy when you have a number of these machines on your network. This way you have everything managed in one central location. So let's go take a look at how DHCP works in a routed network. By using DHCP in a routed network, what I mean is using DHCP in a network that we have routers. Now, what we have up here is a diagram of the Global Mantix worldwide network showing that we span multiple cities and therefore must use routers on our network to have connectivity between the cities. Now, the problem that we run into when trying to use DHCP in a routed network is that DHCP technology uses broadcast communication. Where this is probably most obvious was in the four-step DORA process. Right out the gates, when a client is looking for a DHCP server, what does it do? It yells out, "Hey, I'm looking for a DHCP server." Well, that is a broadcast. And a router, by initial definition, will kill a broadcast. In other words, if a router receives a broadcast transmission from one of its network segments, it will not pass that information on to its other network segments. And for example, here in our drawing, if somebody in Chicago, let's say, were to be yelling out, "Hey, I'm looking for a DHCP server," and the DHCP server was over here in New York, it would never hear it because the router in between the two would cut off that communication. So when we deal with DHCP in a routed network, we have really three options. Now, option number one is to just simply put a DHCP server on every network segment. Now, in the drawing here, that wouldn't necessarily be that unusual. To put a DHCP server in each of the 4 cities kind of makes sense just because of the proximity or the lack of proximity of these 4 cities. They're so far apart geographically that odds are we're going to have an administrator in each location, and that administrator will probably manage the IP configuration for that location and therefore have their own DHCP server. And that's fine. Nothing wrong with that at all. But let's take a look at just this one city right here, just New York City, where we have 500 clients. Now, odds are that we're not going to have a single network segment with over 500 computers on it. It just doesn't make sense anymore these days. Odds are we're going to have 2, 3, 4, 5, maybe more segments to divide up this network to make it more manageable and more efficient. So just as a for instance, let's say that we divided it into 5 segments, each with 100 clients. Well, we're not necessarily going to want to have a DHCP server on each of those network segments just serving the 100 clients on that one segment. So what we can do is our second choice here is we could use what's called RFC 1542 compliant routers. Now, RFC stands for Request for Comment. And I don't know if you've ever read an RFC article before or not, but if you haven't, most people who have will tell you it makes for some pretty good bedtime reading. It has pure technological, dry information. So I will spare you having to go out there and read RFC 1542, and I will tell you that what it says is it has the definitions for how a router can pass DHCP broadcasts onto other network segments. So, if you have RFC 1542 compliant routers, which I will tell you, essentially all of today's routers are compliant, then you can simply use those, and then the DHCP broadcasts that are being made from one segment would be heard by another segment. Now, if you don't have or don't want to implement RFC 1542 compliant routers, there is a third choice. That third choice is to implement something called a DHCP relay agent. Now, a DHCP relay agent is I could say a device, but more often than not, it ends up just simply being a service on a device. It can either be a service, sometimes, matter of fact, very often, it's on the router itself, or it could be done as another, for instance, would be on a Server 2008 computer. I'm going to show you how to set that up in just a few minutes. But the one important thing to know is that the DHCP relay agent will need to always be on the network or the network segment where the DHCP server is not. So the relay agent is always where the clients are, not where the server is. And the reason why is because when the clients yell out, "Hey, I'm looking for a DHCP server," or any other broadcast, the relay agent will hear this and then send that communication on or relay it over to the server. And when the server responds, relay it back to the client. If the relay agent was not on the same network as the client, well, then it would never hear the broadcast either. So I have a drawing here, which will help us to view how this process actually works. You'll see here we have two different network segments separated by a router. And on this segment here, we have our clients and our DHCP server, and all communication between them will be just fine. All broadcasts within this circle will get to every other device within this circle. But over here, we have another segment of clients who are going to want to communicate with the DHCP server, and when they send out that broadcast, the broadcast will be heard on this entire segment, including the router itself. But when it gets to here, that router is just going to say, that's as far as you go. That broadcast never makes it to the DHCP server, and these clients are just not going to have an IP address given to them. So how do we solve this? We solve it by implementing a DHCP relay agent. Now, the DHCP relay agent, as I mentioned before, will be pre-configured with the IP address of the DHCP server. What happens is when a DHCP client sends out the broadcast saying, "Hey, I'm looking for a DHCP server," that broadcast is heard by the DHCP relay agent, who will then send what's called a unicast, or a direct communication, to the DHCP server. Now, why is it able to do this when the client cannot? Because it knows the IP address of that DHCP server. So it sends that discover over to the DHCP server, who will then directly send back the offer to the relay agent, who then, of course, relays that offer out to the client. The client will then send out the request. The relay agent hears the request, sends that request over to the DHCP server. The DHCP server will then, in turn, go ahead and send back the acknowledgement, and the acknowledgement is then, of course, passed back over to the client. So basically, as you can see, a DHCP relay agent is exactly what it sounds like. It's going to relay all DHCP communication from the clients over to the server. And how does it do this? It does this by being pre-configured with the IP address of a known DHCP server on another network. Now, one brief little comment here is, please keep in mind that relay agents are always on the segment where there is not a DHCP server. If the relay agent was over on this segment over here, that wouldn't do any good, because when these clients send out a broadcast, again, if it can't get to the DHCP server, it's not going to get to the relay agent as well. So let's go ahead and take a look at how Server 2008 can be set up as a relay agent. Okay, so here we are back on our Server 2008 computer, New York Member 1. Before I get started in showing you how to implement the DHCP relay agent, I want to explain to you that I have already installed the routing and remote access services and configured this server as a router. Now, don't worry if you start to feel at all lost because you don't know how to set up a router in Server 2008 yet. That will be fully explained in video 4. So if need be, make a note of where you are in this video right now, and after watching video 4, feel free to come back and watch this video again from this point so that you can completely follow what I'm doing here. I'm going to go down here and click on Start, select Administrative Tools, and Routing and Remote Access. Okay, as I mentioned, already have configured this as a router, and I want to show you by clicking on General. You'll notice that we have the 10 network and the 11 network. These are the two network connections that are on this computer. The 10 network represents the 192.168.10 network, and the 11 network represents the 192.168.11 network. So we have these two networks. We are configured as a router. In order to implement the relay agent, I need to right click on General, and you'll see here a selection for New Routing Protocol. So I'm going to select that, and you'll see there's a number of different protocols I can choose. A couple of these we'll go over when we get into the routing video, but for right now we just want to look at the DHCP relay agent. Click OK, and you'll see, boom, it's installed. So I'm going to click on the relay agent. What I need to do now is I need to add an interface or associate this service with one of our interfaces. As I mentioned before, you need to have the relay agent on the network where the DHCP server does not exist. Now, our DHCP server that we had created was on the 10 network. So we're going to go ahead and add an interface. I'm going to right click on the relay agent and select New Interface. And we're going to pick the 11 network because this is the one where there is not a DHCP server. And click OK. Now, don't worry about this screen. This is just telling us how many hops and how long the relay agent is willing to wait in order to attempt this communication. The defaults are generally OK. So I'm going to go ahead and click OK. And the one other thing I have to do is go to the properties of our relay agent and specify the IP address of the DHCP server. So I'm going to go ahead and add that here and click OK. And our relay agent has now been set up. Now I want you to notice right here where it says requests received, replies received, everything's sitting at 0 right now. What I want to do is let's put this tool away for a minute and let's open up the DHCP console. In the DHCP console, one other change that I made is I want to show you here that I've added another scope. What I've done is I've deactivated the 10 scope that we created before, and I've now added the 11 scope. And in the 11 scope, first of all, notice there are no leases. We have a pool of IP addresses, just real simple, from .1 to .5. But one other thing I want you to see is up here, if I go to the if I right click on the server, you'll see here we can add remove bindings. I want to point out that we are only bound to the 10 network. The 11 network is not bound. So that illustrates that this DHCP server is only functioning on the 10 network. So let's go ahead and put that away for now. And what I want to do is I want to go ahead and go over to our client, to our Vista client, and ask it for an IP address and see what happens. So let's go over here and open up our Vista computer. It'll take just a moment to boot. All right, here we go. So what I'm going to do is I'm going to go ahead and I'm going to open up a command prompt, and I'm going to do an ipconfig release. And that is going to give away any IP address that this machine may have previously had. And then what I'm going to do is I'm going to go ahead and put in an ipconfig/renew so that it'll go out there and start the process all over again. Now, one thing you should know is that this Vista computer has been placed on physically, it's been placed on the 11 network. And sure enough, there we go. You'll see we have an IP address of 192.168.11.3. So I'm going to go ahead and let's take us out of the Vista machine. Let's go back to the server and see how things worked. Okay, so let's head back over to New York member 1. Let's go back into routing and remote access and look at the relay agent. Now I'm going to right click and select refresh. And you'll see here that we've got quite a bit of activity. Now the reason we have extra activity as opposed to just the 1 or 2 packets that you would think that would pass through is that obviously there's constant communication that goes on in the network. So I just wanted to show you that we do actually have some activity going through this relay agent. But more specifically, if I go over to the DHCP server and we look at our scope, we look at our address leases, and again refresh, you will see here that we've given out 192.168.11.3 to New York Vista 1. So it all works. So let's go ahead and close out of here and take a look at what we've covered in this video. So in this video, we learned what DHCP is. It's the Dynamic Host Configuration Protocol. It's what allows us the ability to dynamically configure our hosts so that we don't have to go through the tedious task of going through each and every machine independently and giving it a static IP address. We saw how this process works, the four-step process known as DORA. We went and take a look at how to configure DHCP, including installation by adding it as a role on Server 2008. Authorizing, we need to do this within the Active Directory directory service so as to prevent having multiple DHCP servers with overlapping address ranges. We saw how to create a scope and give it some options. We went over the three options for using DHCP in a routed network, which are we can choose to either put a DHCP server on every segment, we could implement RFC 1542 compliant routers, or put in place a relay agent on the networks that don't have a DHCP server. And we saw how to go ahead and use Server 2008 as our relay agent. I hope you had some fun learning how to configure DHCP. I know I did. Look forward to seeing you in the next video.